Hi, this is Jeremy Lickness, and I'm extremely excited to bring you this lesson that is part of the Mastering AngularJS course. In this lesson on debugging and performance, I'm going to share with you tips and tricks and techniques that I've learned in several years of working on a production enterprise Angular application. This will help you better debug your Angular application as well as look at certain areas that can help improve the performance of your application. You can contact me anytime on Twitter at Jeremy Lickness, and be sure to visit my GitHub repo at github.com/Jeremy Lickness. I do have several assumptions before we get started. I do assume that you've watched the Fundamentals of AngularJS video. This is an overview of Angular start to finish. Of course, it's helpful if you've watched the other videos in this course. This is a more advanced video that assumes you've learned the fundamentals of Angular. And I do assume that you've written a few Angular apps of your own. I assume that you're familiar with JavaScript. As Angular is a JavaScript library, it's important to understand the underlying language and tool set. And I also assume some familiarity with browser debugging tools, but I will show you how to maximize your use of those tools for Angular. In the first part of this lesson, we're going to cover debugging. I want to talk about when things go wrong. As a developer, you know that code does not always execute perfectly, and you often run into problems, whether it's on your personal laptop in a staging environment or the dreaded production level defect. So I want an overview of how to look at that and maximize your use of the toolset you're working with. Then I'm going to dive into some specific Angular functionality. We'll cover the exceptional service provided by the exception handler service and how that enables you a place to trap and inspect exceptions that are thrown in your application. We'll cover the captain's log or the log service that Angular has built in. We'll look at the debugger keyword and how to place that in your code when you need to troubleshoot or debug certain areas of code. And finally, I'll demo those three concepts together. Then I'm going to talk about Angular and the DOM. It's very interesting how Angular injects itself into the HTML document object model. And I will demo how you can take advantage of that fact to troubleshoot Angular applications. And then finally, I'm going to demo for you a Chrome plugin called Batarang that has proved a very powerful tool for our team to troubleshoot Angular applications. So let's talk about when things go wrong. So the way that you know a framework works is when it makes life easier. And you may have been part of a team that adopted a framework that seemed to just overcomplicate things, and that's most likely a bad practice. You want a framework to ease what you're doing and not complicate it, and Angular is no different. So specifically, debugging Angular should be no different. If you find it's more complicated to troubleshoot issues, then the framework may be providing more aggravation than value. And so it's important to understand how to troubleshoot your tool and debug to maximize your effectiveness. Fortunately, Angular provides several features that assist with debugging. These include built-in services, the way that Angular interacts with the DOM, and add-ons or extensions like Batarang that make it easier to troubleshoot Angular. So let's take a look at what these are. The first service I'd like to cover provides exceptional service or service for exceptions. Within Angular, all errors that are thrown are trapped and passed to the $exception handler service. That's anything that's run in the Angular context, which would typically be through a digest loop, with the exception of AJAX calls. If an exception is returned from an AJAX call, the way to handle that exception is to use HTTP interceptors. See the web services lesson that's part of this Mastering Angular course to learn more about using interceptors. Now, the default action that the exception handler takes that is bundled with Angular is to delegate to the logger, and that'll simply log the error in the console. So if your application is able to recover, it will continue running and an error will appear in the console if the console's available. However, you may want to have your own special type of error handling. In this case, you can intercept the service. In fact, the recommended way is to just simply replace the service with one of your own so that you can provide more detail, maybe log it to your own service for tracking errors or display it in the UI, etc. And this is an example of replacing the exception handler. Here we're using the factory method because the factory is returning a function, and the signature for the service takes an exception and a cause for that exception, and then you basically do with it whatever you want. So in this case, it's adding to the message to show the cause and then throwing the exception instead of logging it into the console. So this would convert it from a soft error to a hard error that's thrown. The next service that we'll look at is what I call Captain's Log, and I say that because you should prefer the $log service over console log. So everything should go through $log. Now the obvious reason is that $log's implementation is safe and handles the case when the browser doesn't implement console logging. So if you've written raw JavaScript applications before, you know that console log can fail on certain browsers. But more importantly, another reason why you want to use the $log service is because it's a centralized place that you can modify the behavior. So if down the road you want those log messages to be recorded to a service, displayed in the UI, or otherwise intercepted, you can either intercept and decorate the $log service or provide your own implementation. It gives you an easy, centralized way to take care of that. The $log service provides an API with standard levels of logging. So you can log informational text, you can log a warning, an error, or simply a debug statement. And you can use $log provider to enable or disable those debug level based statements. So that means you can write those debug statements in your Angular modules and then in development show those, and in production suppress those so that they do not appear in the console. The image here shows what those messages look like in Chrome's console log. You can see that there's a debug, a warning, an informational, and an error message respectively. And this code snippet shows how you would configure the provider. So during the configuration phase, you simply pull in the log provider, and then you can disable the debugging by calling debug enabled with the parameter false. The debugger keyword is not specific to Angular, but it can be very useful when troubleshooting Angular applications. The debugger keyword is designed to invoke any available debuggers in the environment that you're running your app in. It should work in most browsers, and by implementation, the statement is supposed to be ignored if a debugger is not available in the environment that the user is running. You can use the debugger statement to force a break in code you wish to debug, and that code might get triggered before you're able to supply a breakpoint. So if you have a page that may load and run code quickly before you're able to set that up, you can use the debugger keyword. Or you may just have a lot of code and you don't want to step through the code or find where it is, so you throw in the debugger statement to trigger it. And it's just simply adding the statement debugger followed by a semicolon to your code wherever you wish to break. And it is very important that you remember to move any debugger statements when you send your code into production. Next, let's go ahead and step away from the PowerPoint for a moment and look at a live example of using errors, logging, and the debugger statement within an Angular app. You're looking at a sample application that's designed to demonstrate the features of the exception handling capabilities, the logger, and the debugger keyword. So you can see I've got my application pulled up, and in the console I've already received a message that the controller was created. Now if I tap the warn button, you can see a warning is generated in the console, and I can tap it again and it'll increment with a count of the number of times I generated that warning. If I tap the error button, I generate an error, so that's logged to the console, but then I also have an uncaught exception, and it's showing my custom error caused by undefined, and I've got it here in this error list. So you can see these errors are appearing on my application as I generate them so that I can see them on the page. And then finally, when I tap the debugger button, it throws me straight into the source code at that debugger statement. So now I can start debugging through source. So next, let's take a look at the source code for this application to see how all of these features were implemented. What you see here is the source code for the example that we just ran in the browser. And besides the external reference to Angular, which is part of the sample application, everything else is inline. And this is designed to make it easy to see everything in one place and understand the example start to finish. So the main part of this inline JavaScript is an immediately invoked function expression. And it's immediately invoked with the Angular app. Here we call it Angular module with Angular app, and pass that in to the app variable just to make it easier to reference. So you saw several things in the browser demo. The first thing you saw was a log that indicated the controller was created. That worked because the controller itself has this dependency on the log service. And when it's constructed, so within its constructor function, the log is called to indicate that the controller was created. So that was the first thing. The second thing we did was tapped on the warn button, and you can see the binding here. It calls the warn method on the controller. And within that warn method, we simply use the log service to call the warn function and pass the text warning generated. And that enabled that warning to be written to the console with the warning indicator. For the error logged an error first. So the first thing this function does is passes an error to the log. The second thing it does is throws the exception. So it creates the error. And what happened was you noticed that the error appeared in a list on the actual page. The way that list was created is twofold. First, the root scope, when the application was started, is initialized with an error list that's empty to start with. The second thing we did was replaced the exception handler service, and I demonstrated that in earlier slides. So it's replaced with a function that does a few things. First, it checks to see if we have a reference to the root scope, and if not, it creates it. The reason it's done this way is because at the time this function is created through the factory, there is no root scope. It hasn't been created yet, and therefore we'd get an exception trying to reference the root scope directly. It would create a circular reference because the exception handler and other methods eventually inherit from the root scope. So we lazy load it by just taking a reference on the injector and then grabbing the root scope when it's needed. So that's what happens here. The second thing we do is we push that exceptions message to that error list and then rethrow the exception. So that's how the uncaught error appeared in the console, but the error itself managed to get logged to the page because of these bindings to the error list in the root scope. The final thing that we demonstrated was the call to debugger. So there's a debugger function that uses the debugger statement. And so when this function is called, the first thing that happens is this statement is reached and it causes a breakpoint and launches the debugger at this point within the source code. And then you can see the rest of this is just standard Angular boilerplate. One of the highlights of Angular is that it interacts with the DOM and is in fact very friendly with the DOM. So in most modern browsers you can view the virtual DOM to see bindings, and by virtual DOM I mean instead of the DOM that's initially loaded, the virtual DOM is the DOM that's actually generated. So for example, if you have an ng repeat that repeats 10 times, you want to be able to see those 10 snippets of HTML that were generated as part of that template. So within browsers, you can view that DOM, see bindings, even see commented code that resulted in the rendered DOM, and I'll show you an example of that in a moment. Scope is also bound to the DOM at the level of the controller it was created for, or if the scope was created manually and bound, it's attached to that element within the DOM. So it can be manually spun up and bound to that. Angular provides a method called element, and that's angular.element, that's similar to a jQuery selector. In fact, Angular has an internal version of jQuery that's a JQLite that it provides in case the full jQuery is not available. But either way, this will wrap the element into something that is a node and not just an HTML element, so that you can call various methods. And Angular, in fact, extends those nodes with methods for controllers, injectors, scope, isolate, scope, and inherited data. So respectively, you can see the controller that's acting on an element. You can get the injector that is scoped to that element. You can get its actual scope, and you can see data, which instead of the data that's simply attached to the element, you can see data that may have been inherited from parent areas. Let's take a look at how Angular binds to the DOM and how you can use your browser to access portions of Angular within the DOM. So here I have the exceptions and logging example, and I want to show how to use Angular to debug this. I'm going to go ahead and tap the error button to throw an exception, and then I'm going to right click on it and choose Inspect Element. Now what happens is my Chrome developer tools appear, and you can see here that button is indicated, and I've got a nice view of the Angular attribute. It's calling control.error. But let's scroll down a little bit and take a look at the section that's showing errors. So if we expand that section, you can see we've got these inline comments that show the condition. The error list length is greater than 0, so it is showing this error list. And I can tell by the fact this has an ng-scope class that this section has its own scope. I can also expand this unordered list, and I can see that it was rendered using an ng repeat, error in error list, and then I've got a scope and a binding, and here's the error indicated. Now let's say I wanted to troubleshoot and debug this, and I wanted to know what happens when I tap that error button. Well, let's go ahead and make sure that this is selected. I can either use Inspect Element, or I can use this magnifying glass and tap on the element there, so now it's highlighted. So in my console, what I can do now is I can set my button to $0. So this is the Angular method that accesses the button in the DOM. So now I can do several things. I can type button.scope, and I've got access to the scope for that button, as you can see here. I can type button.controller, and now I have access to the controller that that button is a part of. And I can type button.injector.get exception handler, and I grabbed the injector, and that injector gave me access to the exception handler implementation that I have. Now finally, going back to the button, we can see the scope for the button. We can expand the controller, and if we expand the prototype for the controller, I can see the error function. And I know that this function is what I'm interested in because in the elements it was calling control.error. So if I come back to my console and I go into error, I can right click, show function definition, and now I'm dropped into the source, and I can place a breakpoint right there, and then when I click the button, I'm right where I want to be. So that's a very powerful set of functionality that Angular provides by interfacing with the DOM. Next, I'd like to show you one of my favorite helpers for troubleshooting Angular, and that's a Chrome extension that's called Batarang. If you search for Batarang, you'll find this page which shows the Batarang extension, and as it describes on this page, it extends the Chrome developer tools to help debug and profile Angular applications. And as you can see, this is already added to my Chrome. So I'm going to come back to our example page, and on this example page I'm going to pull up the developer tools, and you can see I've got this new tab called AngularJS. So I'm going to go into that tab and enable it. That's going to refresh the page for me, and you can see I'm already starting to see some information here. So I'm going to widen this and tap the error. And what we've got here is my hierarchy of scopes. Remember, scopes can have child scopes and so forth. So this is actually the root scope that has the error list on it, and we can see the contents of the error list. If I drill down to this scope, you can see this is a controller scope. If I drill down to this scope, it has no models. And then here's a scope that has the individual error entry. So I'm able to drill down and easily see what's going on in my scopes. From performance, what we can see is as watch expressions are fired, it's giving me an indication of how much of the total overall set of watches this contributes to and how long it took, etc. And I can see my watch tree here. So I can see it's watching on the length of the error list, and that's the condition for this header. And it's also watching this collection, so it knows when to re-render the list. And finally, it's watching this specific error binding in case this error message changed. So if I tap another error, you can see that this watch was fired for the collection, and you can see that a new watch is added for that error. If I come back to the top, I can take a look at my dependencies. Now this is a very simple dependency graph because it's a simple application, but as you add various services that depend on each other, those are added to this visual representation. And then finally, under options, I can tap show applications. If I have multiple apps on the page, I can show my bindings, so I can see quickly where bindings are occurring. And I can also show my scopes, so I can see where new scopes are created on the page. Obviously this is very powerful and visual, and will help when debugging Angular applications. It's great to be able to troubleshoot your Angular applications, but you also want to be proactive about performance. So in this section of this lesson, we're going to cover some performance tips. I'm going to talk about performance tools that you can use to analyze your Angular applications. I'm going to introduce a library called Zone that can help you instrument your Angular applications. We'll talk about the law of least Angular and what that means. I'll cover rendering versus binding, because sometimes when building Angular apps you may be data binding sections that don't need it. And we'll talk about a special library called bind once that assists with this. I'll cover tips for dealing with long lists. This is fairly common in web-based applications where you have a long list of data that the user needs to sort through. Talk about the use of ngIf versus ngShow, how to make your watches a little bit smarter, and finally we'll cover lazy loading. The web has certainly evolved as a networked operating system almost, delivering very rich applications to end users. And for that reason, most of the existing web browsers have evolved to provide some fairly comprehensive performance tools. For the purpose of this lesson, I'm going to cover what is the most commonly used set of performance tools, which are the Chrome developer tools, or Chrome dev tools for short. These tools are very easy to launch into. You simply tap F12 when you're on a web page and open that, and I've demonstrated that earlier in this lesson. But there are several tabs that you can use once you open those tools. For example, you can open the network tab and understand timing for your application. You can also move to timelines, and you can view events that are fired on the page and understand where time is spent, whether it's loading, scripting, rendering, or painting. You can take a look at frames to understand rendering performance, and you can look at memory to understand memory usage over time. The dev tools also provide some fairly advanced profiling. You can take a look at the CPU profile to see how long time is spent in various functions. You can take a snapshot of the heap to understand how memory is distributed, and you can look at heap allocations over time. And we're going to focus on a very specific aspect of profiling called the heap snapshot to help troubleshoot one of the most common issues that come up in applications, which is memory leaks. Let's take a look at the Chrome developer tools in action. I'm starting with a blank page in my browser, and I'm going to hit F12, and that will bring up the Chrome DevTools, and I'm on the Network tab. So what I'm going to do is paste the URL for this example and hit enter. So the first thing you're going to notice is that all the network activity has been logged here. And we've got the method, we've got status, you can see the size, the latency, and this timeline shows when and how those various parts were loaded and how long it took to load. So this is great for troubleshooting the size of components that you have on your page. Now on this page I've got this count that's ticking, and then it allows me to add dynamic elements, but I want to show you something here. So on the sources, we can see all the source code. In this case it's just the embedded source as well as the Angular source. And then in the timeline, this is where I can see events, frames, and memory. So I'm going to go to memory right now, and I'm going to start adding some items while I record on memory. So you can see it scrolling across the bottom. You can see as I add more items, the memory increases. Now I can hit this trash can to force garbage collection, and normally that should drop, but you can see we're still pretty steady on a high amount of memory. So I'm going to hit these buttons to start closing these items back out. So now we're back down to the original page, and if I don't have a memory leak, I should be able to hit the trash can to collect garbage and see this drop, but it hasn't. So we obviously have a conflict. The first step in troubleshooting the conflict is to take a look at the source code and try to work out what's happening. So here I've got a controller, and although this example is contrived, it's actually based on a real-world scenario. There are many times you might use third-party controls, and you may need to add those controls to the DOM and then bind a scope to those controls so they work with Angular. So in this case, we've got this compile function. What it does is it creates a new scope based on the parent scope and sets a count on that scope to 0. Then it creates a large list, and this is simply to cause it to take up memory for the purpose of illustrating the example. Now that scope has a watch on it that is called from watching the count on the parent scope, because remember, the root scope for this example is on a timer, and every second it's going to increase a count. And so what this child scope does is it watches the parent scope and increments the count, and then it compiles, and that will compile the HTML and bind it to the scope. So that is Angular's way of basically resolving the template and binding it to scope. Now we even listen for the destroy event on the element so that we can tell the scope to destroy itself. And so that is a functionality that Angular provides. When an element is removed from the DOM, it'll emit this destroy event. So we've got add as a function on the controller, and this is where we just create manual HTML for the purpose of illustration. So you can see it grabs a list, creates a list item, creates a text node that is a data bound to my count, appends this, creates the button to delete it, And when that button's clicked, it simply removes that element. So it wraps this in the Angular element and calls remove. And that should trigger the destroy event, so on and so forth. Now, this code obviously is working as far as adding the nodes and removing them, but it is not successfully releasing memory. So we want to take a look and use the Chrome developer tools to figure out why. Now I'm back in the Chrome developer tools. I'm going to refresh the page so the count has started and just collect garbage so I have a clean starting point. And this time I'm going to go into profiles and I'm going to take a heap snapshot. So I'll just hit this record button and you can see it went through and processed the snapshot. Now I'm not going to do anything with it yet because the most useful way to use a heap snapshot is to compare before and after. So what I'm going to do is add several elements and then I'm going to give them some time to count up. So now we've allocated that extra memory. And then now I'm going to remove the elements, and this should restore us to our initial state if everything's being managed correctly. So I remove these elements and then I'm going to come back into the timeline and collect garbage again, and then I'm going to take another snapshot. So now we have two snapshots, and notice the second one is significantly larger than the first one. So what I can do, and I'm just going to expand this, is I can go into the comparison view, and this will compare it to the previous snapshot and show me the difference. And what we see immediately, this is sorted by size, is that for this array type, we've added 2000, deleted 121. The change in size is over 4.5 million bytes. So this is obviously where our problem is. These arrays aren't being cleaned up. But what I can do is expand this and go into an actual array, and you can see these are all allocated the same size, so that would point to the artificial arrays that we're creating. But let's go ahead and click on this, and what happens on the bottom is we get what's called the retaining tree, and this is going to give us an idea of what is referencing that, because remember we called destroy on new scope, and so that should have been eligible for garbage collection. However, we can see in this retaining tree that we've got something referencing it. If we take a look at it, we can see that we've got this scopes, we've got this watchers, and so on and so forth, unpatched apply function, etc. So let's take a look at another one and see if we have a similar thing. And again, we've got this scope that has a watcher. So something actually still has a watcher that's pointing to our scope, so we need to figure out what that is. Now I'm back in the source, and the one watch that I create in this new scope is this watch here, where I watch the parent count so I can increment my count. Well, what's interesting about this is the watch itself is created on this parent scope. So what's happening is when this child scope is destroyed, that scope may be destroyed and all of its watchers and listeners are removed, but the parent's watcher is not removed. So what we can do is just add a snippet of code here, and basically if I've checked that I am destroy aware, I can call this method to remove the watch. So what happens is whenever you create a watch, Angular returns a function that you can reference. So here I'm storing it on the scope, and calling that function disables or removes that watch. So it's just a simple line of code, but because our performance analysis led us to the fact that the watcher was retaining the reference, we're going to go ahead and remove that watcher because we obviously don't need it when the child scope goes away. So we'll make this one change and save it, and then we'll take a look at how that changes our memory profile. So I'm back in the browser. I'm going to refresh the page, go to my timeline, collect garbage, and then start recording. So now we're looking at memory events again. This time I'm going to check destroy aware. So that's going to add the additional code that removes the watcher that we just added. So I'm going to start adding all these elements, and you can see the memory goes up significantly as we would expect. I'll collect garbage, but because those elements are still there, we still have a pretty good memory signature. So now let's remove these elements. You can see memory hasn't changed that much yet, but let's go ahead and force garbage collection. And you can see immediately what happens is this drops down to almost the start value. So that tells us that we're managing memory correctly, and as we add and remove items, they're appropriately being detached from the DOM and are eligible for garbage collection. There's a lot of functionality available in Chrome developer tools, and that could last an entire lesson, so I'm going to move on and share another tool called Zone that you can use to instrument your projects. Zone's part of the Angular project, but interestingly enough, it does not need to be used with Angular. And you can see the URL there. It's github.com/angular/zone.js to get the source. What Zone provides is an execution context that persists across asynchronous tasks. So it gives you a way to very generically hook into asynchronous events, whether they're timeouts or web service calls, for example, and do something with those. It's considered thread local storage for JavaScript virtual machines. And it's what we call turn-based. So for example, when you bootstrap your app, that's really a turn. That script gets a turn in the JavaScript event loop. Then you might wire or bind a click event, so that click would be a turn, or you might fire a timer so that timer is a turn, and then you can hook into those various tasks. And through Zone, we're able to instrument things like time and counts. Now I'm going to show a very brief demo of Zone, but for more information and to dive into it more deeply, refer to the URL that you can see, jeremylickness.github.io/zonejs. That's an online presentation that goes much more deeply into what Zone can do. Now I'm going to show you a working example of using Zone. Once again, I'm looking at source code, and this source was actually copied from the previous example that we were doing troubleshooting. And as you can see, we've got an app run with a root scope and a timeout, and it's incrementing the count every second and then resetting the timeout. Now what's a little bit different is instead of defining ng-app in the HTML here, you notice there's no ng-app. I'm manually bootstrapping Angular, and this is how you do that. Angular.bootstrap, I'm calling it on the document, it can be whatever element, and the name is Angular app. The reason I'm doing that is because I want everything with Angular to run inside of a zone. So here I'm forking a custom zone. And again, there's a lot to how Zone works, but in a nutshell, this creates a zone, and anything that happens within this run function is going to be part of that zone, and so we'll be able to wire up instrumentation. So what are we doing with this zone? Well, here's where I define the custom zone. And for that custom zone, I'm defining an asynchronous count, a start time, and a task start. And then basically before the task, that task start gets set to a timer and the asynchronous count is incremented. And then after the task, we're computing some times and logging them to the console. So what's amazing about Zone is instead of having to add this code to every single asynchronous function, the fact that I ran the bootstrap within the zone means any task is going to automatically run through these filters. So before that task is run, this code will execute, and after, this code will execute. So again, notice that the Angular code itself has no specific hooks in it. We're just bootstrapping it inside the zone. So let's take a look at how that appears within the browser. Now I'm in my browser and I've got the console open, and I'm about to navigate to this instrumentation with Zone example. So we'll click on that. You can see this count is going, but you can also see the console is logging all of these tasks. And what's happened is, because we wrapped Angular with zone, every time there's a task, that before task is recording the time, and then it's logging how long it takes the task to run, and we can see how many total tasks there were as well as total running time. Now these short tasks are the tasks that increment the counter, but you can see up here we had one task that took a while to run, maybe a little bit longer than the other tasks, and this was really the task that Angular used to bootstrap the application. So all of the initialization took around 23 milliseconds, another 2 milliseconds here, and then the tasks start running really quickly. But the nice thing about this is, again, we did not have to change any of the tasks or timeouts or function calls themselves. This was all done automatically through Zone and by forking that Angular bootstrap within Zone. I'm going to talk briefly about what I call the law of least Angular. And basically the law simply says this: HTML and CSS provide a rich set of functionality, and declarative code is easier to understand and troubleshoot and accessible to non-developers. And although Angular is very popular, there are still more developers who understand plain JavaScript, HTML, and CSS. So for example, whenever possible, use CSS rather than programming changes to the DOM, for example, JavaScript animations in Angular. And whenever possible, use built-in HTML features rather than trying to reinvent them in Angular. In essence, you should be able to create standalone JavaScript objects that know nothing about Angular that you could plug into any application and then extend them by including them within the Angular system. And this enables your application to rely on standards that can provide a basic framework for everyone to tap into without creating too much proprietary or Angular specific code, and is useful when doing a lot of things within Angular for both performance and making it easier to debug. Another important concept to understand is the difference between rendering and binding. Now, one of the nice features of Angular is that it provides data binding, and it's very easy to data bind in Angular. However, data binding can be very expensive due to listeners and watches. In other words, every time you data bind something, there's code generated that is looking at that functionality and creating overhead and cycles. There are many times you really only want to render static data, and it may seem just easier to render that data using data binding, but you get the side effects of those listeners and watchers. So in those cases, you probably want to consider actually rendering it, and that's emitting the HTML rather than binding it. Now I will show you the difference between rendering and binding. In this example, my goal is to display a static list of numbers. In fact, I have 1,000 different randomly generated numbers that you can see I'm scrolling through here. And right now, just with this simple application, rendering that list and having a few buttons, we have 16 watchers in our application, and I'll show you in the source how we get those watchers. And if I refresh, you can see the count remains consistent. So let's switch to data binding. This is rendered statically. So we switch to data binding. The same list is rendered, but now our watch count is up to 1,017. So that's significantly larger, and the reason is that because each of these items is data bound, there's a watcher for each entry in the list in case that value changes. So we can come back to our rendered set and see that that rendered set only has 16 watches. So let's look at the source and see what the difference is. This is the source code for the example, and you can see I've got the refresh button that counts the watches. We've got a toggle button. Then we've got a list that's a rendered list. So this is a custom directive that I created, and I'm passing in the list to render here. And then this is an approach using data binding. The second list uses ngRepeat and simply displays the number over here. Our directive is fairly straightforward. It pulls in the reference for the list and evaluates that off the parent scope, because remember, this directive spins off a child scope. it makes a copy of the list, and then it spits out divs and spans for that list. So this is what I mean by manual rendering. So there's no data binding going here. We're emitting actual HTML. And then it sets that in the element and immediately destroys the scope that was created for this directive because it's no longer needed. So that's how the directive works. And then the only other code here is special code used to count the watches. And we take advantage of the fact that Angular is bound to the DOM to iterate through the DOM, find scopes within the scopes, find the watchers on those scopes, and push them into a list so that we can count them. But the main difference that you're seeing is the directive that emits HTML for the static list versus the data-bound control, and that's a difference of 1,000 watches. Of course, it's not really practical to create a new directive every time you want to render some static data, and it doesn't feel clean to emit hard-coded HTML. That's part of why Angular is nice, because it lets you use reusable templates, etc. So fortunately, there is a library out there that makes it easy to do one-time static data binding, and that's called the bind once library. And you can see here the URL to bind once, and it's a library that you can pull down and include as a module within Angular, and it provides high performance data binding. The module that you would include is pasvaz.bindOnce, and I'll show you that in source. But what's nice is once you include that module, you can use directives similar to Angular. You just replace the ng with bo for bind once, and it automatically handles removing the watchers and only evaluating one time. Bind once is very easy to use, as you'll see in this next demonstration. The main source code for the bind one example is exactly the same as the previous example. So we've got the code to look for watchers here. We've got our controller with our long list and our count watch function, etc. What's different is we include the bind once module, and so when we define our application, we're passing it as a dependency into that Angular app. And then in the data binding section, I'm still using ng repeat, but I'm adding this bind once attribute. And there's two places I'm using bind once. First is in the repeat itself. I'm indicating it's a bind once repeat. And then second, instead of using the mustache template for the number, I'm using this bo text, this bind one text directive. The difference is visible here. The watch count is only 8, even though I'm still rendering 1,000 items. So that's what's nice about this bind once library, is you're still able to use your templates and data binding, but by just swapping out the directive or adding an extra attribute, you're able to avoid all of the overhead of the extra watchers and listeners. It's very common to have to deal with long lists in Angular apps. In fact, the production application that I worked on contained a specific grid that had millions of hierarchical rows. So it's a very real problem to solve, and of course the main way we deal with this is to use paging, but sometimes for reasons of performance and otherwise it may not be feasible to page on the server. So in that case, there's several approaches you can take. If you have an extremely long list, you can condition the display of the list items instead of re-rendering the entire list. And then one of my favorite approaches is actually to use two lists. One of those lists holds the underlying data, and the other one is just a list for rendering, so the current page. And if you're rendering the list, instead of watching the entire collection using the $watch collection function, use a hash or another mechanism. In other words, you can store some special property on that list, and then you control when a list item changes, and you can refresh that property and watch that property instead of the entire list. Of course, if you're rendering with ng repeat and the list is not going to change, consider implementing bind once as we showed in the previous example. Now I'll demonstrate for you the example of using two separate lists to handle an extremely long list. What you're looking at is an extremely long list that has 1,000,000 entries, and this was generated just using math.random, so it's a collection of random numbers. But you can see here I've got paging controls, and I can page through the list relatively quickly and jump to the end of the list or jump to the beginning of the list. And if we pull up Batarang, so I'm going to use F12, enable Angular, you can see at any given moment we only have enough scopes to handle that given page. In fact, we can take a look at our performance and we can see that our watches are just limited to that page, and if we knew these numbers weren't going to change, I could even use bind once and avoid even that set of watches. So very efficient and well performing. Let's take a look at the source code. Here we're looking at the source code for the paging app, and you can see that the buttons for paging basically condition themselves based on the current page and what the total pages are. So that's pretty straightforward, and clicking on it is just directly setting the current page. So we know that there's going to be a watch or something triggered on the current page. So let's take a look at the source code. So to start out with, the controller creates this list that has 1,000,000 entries, and it's just pushing math.random, and then it's calling refresh pages. So something new here is, instead of using a watch for the current page, which can be inefficient as we've learned earlier, I'm using a property. And with this property I can define a getter and a setter. And the getter simply returns the current page, but the setter, when that current page is updated, can trigger the call to refresh pages. So this is a way, using just built-in JavaScript and the law of least Angular, instead of using the Angular specific watch functionality, we're using the built-in properties. And then here we're using another technique to group the functions of the controller. You may have seen in previous examples there was a lot of prototype this, prototype that to set the functionality. In this case, we can use Angular's extend on the controller's prototype to define those properties in one nice object. So it's just a little bit easier to encapsulate and read. So here we're initializing a page size, current page, next page, so on and so forth. The main functionality happens in refresh pages. That's where it computes the total pages that index the previous page, and then if the current index changes, it does a couple things. First, it goes through this display list. So remember, two lists. One list that is the full 1,000,000 items, one list that's simply the current page. So whatever's there, it pops it out of the list, and you can look up array manipulation, and there's several ways to clear an array, but this is one of the fastest ways, especially when we're only dealing with 20 entries. And then it takes the index and simply iterates through and pushes those items back into the list, so those are bound and refreshed on that page. And that is it for implementing the double page functionality. We've got a nice, fast, efficient way to page through 1,000,000 client-side records using these various techniques. Another important tip when using Angular is to understand the difference between ng-show and ngIf. A lot of times you may find yourself gravitating towards the use of one or the other, but they do fundamentally work in a different way. With ng-show, the expression is always evaluated. So whatever template or expression or functionality you have, it's actively bound, listeners and watchers are applied, and you take all of that overhead, and if that value is set a certain way, it simply hides that div. Now this is something that is useful when you have a portion of the display that is just conditional based on user input, so you want to evaluate it, but you may be showing or hiding it for purposes of just a nice presentation. On the other hand, there are times when you may evaluate part of the screen and you never want to show it, or you only want to show it under very specific conditions. In that case, you can use ngIf. In ngIf, the expression inside that container is not evaluated if the condition fails, and it's actually removed from the DOM. So this gives you the advantage of not having listeners or compiled scope for that container if that value turns out to be falsy. So this is advantageous because it can save a lot of performance if you're simply not going to show that section of the UI. Keep in mind ngIf is reevaluated and that DOM node will be added if that condition becomes true. So it's a trade-off of taking the hit when it's first rendered and then just hiding the template versus lazy loading it and only bringing that in if that condition becomes true at a later point in time. As you may have guessed, managing your watches is very important in Angular. And here we've got a few examples of ways you can be a little bit smarter and consider performance when designing your apps. So in the first example, it's quite common I've seen in apps to use a function call to evaluate some sort of expression that conditions part of the application. The problem is that every time digest runs, which is quite frequently, that function has to be called, and if it's performing quite a bit of work, that can lead to a lot of overhead because it might be called multiple times. A better approach is to use a simple property, and then as was shown earlier in this lesson, you can update that property in conjunction with other properties being updated on the model. In other words, if you have a computed property, you can compute that when those other properties change and simply watch the property itself. Another important aspect when dealing with collections, although Angular does provide watch collection, that is going to generate a watch on every single item within the collection. If you have a central way of knowing when that collection changes, a better approach is to create some sort of hash key or identifier version. That way, anytime something changes, you just update that one property, and you can watch that single property as opposed to having to watch the entire collection. The final tip I'll share is another one that you've seen in this presentation, and that's lazy loading. Avoid instantiating objects or taking on the memory overhead of components when they're not always used or needed in a part of your app. Instead of referencing the service directly, reference $injector. Then you have two options. You can call injector.get when you need to get a reference to that component or service, or you can call injector.instantiate to create a new copy on the fly. And that's even if it hasn't been registered with the dependency injection system yet. Here are a few related links to this presentation that can assist you with further information. The first is the source to the examples that you've seen in this presentation. It's available on GitHub at the repository you can see here. The second is an active version of these examples. So the first link is to the source code. The second link is a running version that you can interact with and hit in your browser to see the examples live yourself. And then finally, there is a link to learn more about Zone.js. That's a presentation of mine that goes into the details of Zone. This is the end of the AngularJS debugging and performance lesson that is part of the Mastering Angular course. My name is Jeremy Lickness. You can follow me on Twitter at Jeremy Lickness and view my various open source projects on my GitHub repository at github.com/Jeremy Lickness.